be sitting next to them.
So just to give you guys a little overview of what's to come, we got about a month left. We're going to do stuff all the way to the end. The pace won't be as fast. I expect with fewer students, we're able to process things a little bit quicker and get through things and have more time in class to kind of get to stuff. So I probably won't be talking as long on every single day, but I plan on doing 2 sets of topics. We'll have a test over the first one. The second one will be exam only stuff, because I'm not crazy to where I feel like I need to cram another test down your throat the week before you have an exam. Just put it on the exam. Is everybody okay with that? So this sequence and series stuff will be the last test, and then we'll do a little bit of something after that, maybe some vector stuff. It's a good pre-calculus topic. But that would be that'll get us to the end. Sound good? So the plan today, we're going to talk a bit about geometric sequences, like what the explicit and recursive formulas for those look like and how to write those formulas, generate terms of a geometric sequence and stuff. We already talked about what that was last time. And that is all I want to do today. It's just kind of do kind of the same thing we did last time, but for geometrics, and then give you time to practice some delta maths. The following class will have some like work together time in class. I have a couple of handouts on sequences. We'll partner you guys up. We'll give you guys time to work on things and present things and do some of these problems together. But I got a couple of handouts on sequences that we'll do some of, and have you guys kind of get up and talk to each other and be active and get through some of that, and then we'll, follow up with series. Sound good? And that'll be the last topic. So probably, we have what, probably not, probably test the week after next. It's probably where we're kind of looking. So not a ton in this chapter, but that's okay. And then we'll talk some vectors, and that'll be to the end of the year. At least that's what I'm leaning. If I come up with something different, I'll let you know. But I think that'll be the end. Okie doke. All right. So who remembers what the defining characteristic of a geometric sequence was? Yeah, we called that a constant common ratio is the vocab there, but the pattern is each term is multiplied by something, like a constant. So our explicit formula for our geometric sequence is A sub n equals the first term times that constant common ratio to the n minus 1. What type of function does this look like? Where's the variable at? In the exponent, right? So this should look like a exponential function. So when we say arithmetic sequence, you think linear function. When we talk about geometric sequence, we think exponential function. Arithmetic linear, geometric exponential. And basically all the same properties apply. So anything that we did with exponentials, we can do with geometric. Everybody feel okay? The recursive formula is just r times the previous term, and we have to designate where the start is, the starting term. Okie dokie artichokes. All right, let's crank here. So what we'll do is we'll do some examples of now writing recursive and explicit formulas from different information. And 15 or 20 minutes later, I'll be done for today. Ideally, I would have done this all together, but didn't feel like it was a great idea that last day of class. So we'll separate it and give you guys some time to work on the next Delta Math. Or if you haven't finished the previous one yet or started it, you could bang away at that one first if you want. The second one's a tad bit more. Okie dokes. So let's say we want to write the explicit and recursive formulas for this sequence. So does it tell me what type of sequence it is? Nope. So our first task is would be to figure out if it's arithmetic, geometric, or something else. What do you see here? Are you sure? No, it's not, is it?
It's times it by 2.
Yeah, it's geometric. We're just multiplying by 2 each time. And then the piece that I'm going to need is this guy right here, because he's the first term. So my explicit formula is the first term times r to the n minus 1. So that's going to be 3 times 2 to the n minus 1. We're all done. Pretty easy. If I want the recursive formula, the recursive formula is r times the previous term, and we need to give the starting location. Well, again, we know the r is 2, and we know that first term was 3. That's it. We're all done. The hardest part about that was probably getting the r out of it, and then you're just filling into the formula. You guys feel okay? Okay. Let's say that we have then, we'll tell you it's geometric. And we're telling you the third term is 4, or is 1/4, and the seventh term is 4. So here it's not quite as easy as it was with an arithmetic sequence where we can just calculate the slope and go directly. What we're going to do here for a geometric is we're going to set up a system of equations. So I know using the first piece of information, if I plug in 3 for n and 1/4 for a sub n, I have this equation. Oops. And then I can do the same thing for my second piece of information. That's going to form a system of two equations. I'm going to simplify those down just a skosh and write them in a slightly different order so that the equal sign is kind of on the right-hand side. Everybody feel okay here? Now, to solve this system, what I'm going to do is I'm going to think about these as equation A and equation B. Notice the two variables I want to solve for, the A1 and the R, are being multiplied together. So if I want to solve this system using elimination, instead of adding and subtracting these equations, I'm going to have to be multiplying or dividing these. Typically what I like to do is I'm going to choose the equation that has the bigger exponent and divide that equation by the one that has the smaller exponent. Now, it doesn't really matter which order you do it, but it just kind of like keeps the algebra a little bit neater if you go in this order. So there I've just divided the left-hand sides by the right-hand sides. I notice that, hey, the A1s cancel and the R's reduce. And I know 4 divided by 1/4 is the same thing as 4 times 4 over 1, so just 16. So now I have an equation in just R, so I can solve for that, right? How do I solve R to the 4th equals 16? Or you could do 1/4 root, right? You could square root twice, that's fine. But let's just do a 1/4 root. Now, because this is an even root, what do I have to remember to include? Plus or minus. And if you typed in the 4th root of 16 into your calculator, you'd get 2. Do you know how to type in the 4th root of 16 in your calculator? So if you look at your calculator, if you press the math button and you choose command 5, it'll allow you to do any index of radical you'd like.
Like the log base one.
Just like the log base one, yep. So you just type it in the blank and the 4 in the blank spot, and there you go. Cool? Okay. Now, we're not quite done because we still need the A1, right? So, let's pick one of the two equations to plug this R back into to solve for A1. I'm going to pick the first equation because it has the smaller exponent in it. Typically, that makes life a little bit easier. Now, I luck out here because what's going to happen when I square plus or minus 2? I get 4 either way, right? Because positive 2 times positive 2 is 4, and negative 2 times negative 2 is also 4. So I'm not going to get 2 sets of A values, and boy, that's kind of nice. And then we'll just divide both sides by 4. So I have A1 is 1 over 16. So my answer for my explicit formula is I get 2 separate answers. I get one where the R value is positive, and a second where the R value is negative. That can happen on occasion. Doesn't happen every time, but will on occasion. Everybody happy here? And then my recursive formula, I'll have r times the previous term, and then the first term. Or, remember we had two different possibilities for r. So again, we'll have two different possibilities. How do you guys feel here? It's okay? Okay. What if I ask you to go from like the explicit to the recursive? So if I look at this explicit formula, I haven't told you what type of sequence this is, so we need to look at it. You should be able to look at the formula and be able to tell, is this arithmetic or geometric? Does it look like a linear equation or an exponential? Linear, which means it's arithmetic. So for arithmetic, the recursive formula is d plus the previous term and the first term. What is the d going to be? Should be able to just look at the equation and see it. Good. It is 7. Remember, d was the same as slope. So I have that. The other piece that I need is the first term. How am I going to find the first term? Just going to plug 1 in for n. Shoot, Mr. Kulik, I have the explicit formula. So there we go. And find you whatever term you want. That's easy. The explicit formula makes it a breeze. Do you guys feel okay there? You could do the same thing with like an explicit or a geometric, right? Makes no difference. The formula is different, but it's like the same thing. You pull the r and you plug in 1 for find the first term and you're done. Is that okay? What if we go the reverse direction? Let's say we're given this explicit formula and we want to produce this recursive formula, and we want to produce the explicit. First thing you want to do, we're not told what type of sequence we're looking at, so we have to look at the recursive formula and decide, based on the form, what type of recursive formula do I have here? Is it arithmetic or geometric? Geometric. How did you know? Well, it's recursive, so it's not going to look like a linear equation, but it's because it's being multiplied, right? Geometric is repeated multiplication, so the recursive formula has the multiplication in it. Arithmetic is repeated addition. That's the arithmetic formula has the addition in it. So just looking at the recursive formula, because I have something times the previous term, that tells me it's geometric. And in fact, it does better than that. In fact, that tells me the r, right? And I have the first term. So like Mr. Kulik, that's like everything I need, right? Student, it is. That is like it. What do you think about so far today? What if I told you this as far as I'm going?
Great.
Yeah.
That sounds silly, but like I feel like you're all close.
Yeah. So what do you think on the test? What do you think you're going to need?
I
Yeah, your note card, you're just going to do a good job and label the formulas. And like, if you can use the formulas, if you have them written down, you don't have to memorize them. You just have to be able to use them when you see them, right? And that should be pretty realistic. Yeah, go ahead. Get those steps in, you know? You're welcome. All right. So, oops, that's not what I want to do. I want to do this. Guys. So, just to show you what you'll be working on based on this. So your second Delta Math, distinguish between arithmetic and geometrics. So if I look at this guy, what's going on here? Arithmetic or geometric? Good. Because the common difference is equal to? Guys, -6. Right? Because you're just subtracting 6 each time. Okay? That's not hard, right? That's like once you get going, like that's a 10-second problem. Maybe you need to arithmetic your calculator a little bit, but like if you weren't totally asleep, you're going to be all right. Here we're looking for the 8th term of a geometric sequence. So we just write the explicit formula and plug in 8 to it. Everybody's okay? Okay. Here we're given the first 3 terms of a sequence. It says then to find the 10th term, and it says you can write your answer as a decimal or whole number and to round to the 1,000th if necessary. So this one looks like one there you may, actually with the 25ths, I don't think you'll have to go all the way to the 1,000th, but maybe you do. Is everybody okay there? So again, you just write the explicit formula, and then you bada boom, bada bing, plug it in, and you're good to go. So here is like you're given the first term and the 5th term, and you want to solve for the common ratio. That's just like we did, except you're not going all the way to write the explicit formula, but you set up that system the same way. Here we're just writing an explicit formula for the sequence. The sequences could be arithmetic or geometric, so you have to check that first. Here you're given this a sequence and it's multiple choicing. Same idea though, with the explicit formula. Here's just some recursive sequence practice. So you're just generating terms of a recursive sequence that's not necessarily arithmetic or geometric. And then the last ones are just converting back and forth between explicit and explicit and recursive sequences. But that's it. What do you guys think? We can handle this, I hope?
Yes.
All right. You guys have a solid hour left here. You should try to bang out at least one of these Delta Maths in this hour here, right? Like, do yourself a favor. Use your class time. You can work together. You can partner up. You can push your desks together. You can talk about what's going on. You can help each other out. That's all fine. In fact, I encourage it. I think it's really healthy. Just be productive, okay? So like cool it on your smash brothering or your clan clashing or your TikToks or whatever else you're doing, and like let's be productive here, okay? I'm happy to give you guys time in class to work on stuff provided we're being productive. So let's like not betray that trust here on the first day and do a good faith effort to like get some of this done. What do you say? I love it. Let the learning begin, guys.